Again, it's a rich thing.
What is going on, guys? Welcome back. In today's video, we're going to build a simple Android calculator app in Python. And for this, we're going to use Kivy, which is a cross-platform app development framework. You can use it to create Android apps, iOS apps. You can use it to create Windows desktop applications, Linux desktop applications, and so on. And in order to install it, we're going to open up a command line and we're going to type pip install Kivy, like that, pip install Kivy. And once we have that, we're going to create a separate directory for the application, because otherwise in the compilation process it's going to include all the files in the subdirectory and all that. So we want to create a simple directory with a Python file in it. And in this Python file, we're going to start by saying from kivy.app import app, then from kivy.core.window import window, even though I think that's optional. We're going to see in a second or in a couple of minutes. Then we're going to import Kivy itself, and we're also going to import from Kivy uix dot box layout. We're going to import the box layout. Now, what we want to do now is we want to create an app, the app itself, which is going to be neural calc for neural calculator. So the class is going to be neural calc for calculator, and it's going to extend from app. It's going to inherit from app, and all it's going to do is it's going to have this build function here with the self parameter, and it's going to return an instance of something that we haven't created yet, which is going to be my root. Now my root is going to be a class up here, so class my root, and my root is just going to be a box layout. So this is just one layout type that we can have. And this box layout thing, it's going to have a constructor. It's going to call the super constructor on my root and on self. So init like that. And basically, this is going to be the UI root element. We're going to design the UI not in Python, but in a Kivy file. But that's basically the structure. We have the my root, which is a box layout. We have the app, which is returning this layout here with all the sub elements that we're going to define. And in order to have the app running, we're going to say neural calc equals neural calc, and then neural calc dot, I think it was run, right? There you go. All right, so now let's go to the layout. We're going to create a new file, which we're going to call neuralcalc.kv. Now it's important that you name it exactly like that. Now, not necessarily neural calc, but you name it in the same way that you named your class, and all in lowercase letters. So if your class is hello world, you want to name this hello world in lowercase .kv. So then here we can design the layout. We're going to start with the root element, which is my root in angle brackets, and we're going to choose an orientation for that layout. So this layout orientation is going to be vertical, because we want to stack vertically the individual elements, and inside of that box layout we're going to have different layouts. So we're going to have for the individual numbers, so let's look at the Windows calculator. For the individual numbers, we're going to have this grid layout here, like in the Windows calculator. And yeah, for this we need obviously a grid layout, and the other elements are going to be arranged in the box layout. So the first thing we want to have is we want to have a basic field where we have the current calculation. This is going to be a text field, a text input, and this text input is going to have an ID, which we're going to call just calc field. Now, in order to make this accessible in the code, we need to define it up here. So we need to say the calc field in the program is going to be the same as the calc field in this design here, and the height of this is going to be 200. I think it's pixels. Not sure. The size hint is going to be overwritten by 1 and none. This basically means that we override it so that we can choose the height ourselves. And then we're going to make this read only, which is written as one word. So read only is true, and disabled is true as well. Now I always need to look at my second screen because I always forget the exact names of these parameters, so you can also look them up in the documentation, obviously. So then the font size of this of this text input is going to be 64. And this is basically just a field with the calculation. So when we press something, we want this field to be filled up with the calculation to be evaluated in the end. Now, for all the other things, we're going to have a grid layout, or I think for all the other things, because we're going to have the buttons, we're going to have, no, at the bottom, we're also going to have one box layout. But in the beginning, we're going to have a grid layout for the individual numbers, for the plus, for the multiplication symbol and all that. So the grid layout is going to be that. We're going to have 4 rows. Rows is 4. Columns is 4 as well. Then we're going to have a padding of 10 and a spacing of 10. Very simple thing. And then the height of the whole grid layout is going to be 400. And then we're going to say size hint is 1 none again, so that we can overwrite that. And inside of that grid layout, we're now going to have a bunch of buttons. So we're going to say a button. The text of the first button is going to be 1. The font size is going to be 26. And we're going to also have an onPress. So the onPress is going to be a function that is going to be defined in the Python script. And this function is going to be called the root.calc symbol. This is a function that we need to define, and here we're going to pass 1. And the basic idea is that whenever we press a button that calls this function is going to take the parameter of the symbol, and it's going to add that symbol into the text box. So we can implement that right away. It's going to be a very simple function. It's just one line. So def calc underscore symbol. It's going to take symbol as a parameter. And it's going to just say self.calc field, which is what we defined up here. Remember, calc field. This dot text is going to be set to string, or actually not to string. We're going to just say plus equals the symbol. So we're just going to add to the string another string. So even the numbers, as you can see, are strings. We're not adding 1 as an integer here. Now we're going to copy that, and we're going to do this a couple more times. So let's do this 8 times. I'm not sure if that's enough. So we're going to have this be 1, 2, 3. Now we need to be a little bit careful here, because we cannot just go with 1, 2, 3, 4, 5, because what we want to do here, let me show you again the Windows calculator. As an example, let's go to standard. You can see that we have here 1, 2, 3, and then a symbol. Now we're going to do 1, 2, 3 up here, but still we have the symbol. So the first one, the second one, the third one, but then we have one of these operations here. So we want to have 1, 2, 3, and then a symbol, then 4, 5, 6, another symbol, and so on. So we're going to change this to 1, 2, 3 here, and this is going to all, they're all going to call the same functions, the same function, but with a different parameter. And the fourth button is now going to be a basic plus, and it's also going to add a plus to the calculation field. And then we're going to proceed with 4, 5, 6. Then we have 4, 5, 6. There you go. And then we have a basic subtraction. So that is going to be minus. That is going to be minus. Then here we have 7, 8. Okay, now we don't have enough buttons. 7, 8, then 9. And then we have basically multiplication. Now let me just see how I arranged this the first time. We had the numbers. Okay, then we basically had, okay, right. So basically what we do now is we also add this 4 more times, because now we're going to have the brackets. We're going to have an opening bracket, and we're going to have this here as well. We're going to have 0, which is going to be there. Then we're going to have a closing bracket, and then we're going to have a division symbol like that. And after that, we're going to have a box layout, but I think we should already be able to see something if we run the script, if I didn't make any mistakes. There you go. So this is the basic layout. We have this here, and I think that also the function should already work. There you go. So you can see that I can type certain things in here. 8 divided by 9. Oh, the problem is that I didn't change everything. We still have 1 here, which should be a star, and we still have these ones here. So 7, 8, 9, but the rest should be okay. So we're almost done. We need a couple more things, and of course we need also an equal button or an equals button, which says, okay, I want to call a function that calculates the result and displays it. So we're going to do this outside of the grid layout. We're done with the grid layout now. And we're going to say after the grid layout, we have another box layout inside of the box layout, which is my root. And inside of that box layout, this is going to be a horizontal one, because we are only going to have 3 buttons. And we're going to say we still want to have a padding and a spacing. We're going to choose one of 7 here. We're going to choose a height of 100. Again, overriding the size hint. And then we're going to have a button. I think we can actually copy the buttons that we have here 3 times. So then we have the button. The left button is going to be a simple dot for the comma. This is just going to add dot. Then we're going to have a C for clear. This is going to call a different function. It's going to call the clear function. And here we're going to have an equal sign, which is going to call root.calculate, or let's call it get result, like that. So we need to implement these 2 functions, and then we're actually done. We only need to compile it to Android. So first of all, we have def clear, and all it's going to do is it's just going to say self dot what was it, calc field dot text is going to be empty. That's all it does. And then def get result is going to be simple as well, because all we're going to do here is we're going to say self.calcfield.text is going to be the result of the evaluation of the text. So self.calcfield not calc symbol, calcfield.text. Whatever is written there, the formula that is written there will be evaluated in a Pythonic way. And we want to have a string as a result here that we add to the calculation field. So now if I run this, we're going to see, unless I made any mistakes here, that if I say, for example, 8, okay, we have a problem. I think that's just the size. There you go. We need to set the window size, I guess. Oh, by the way, we forgot one very important thing. We need to require a certain Kivy version, because we need to make sure that we have the proper version. On my phone, for example, 2.0.0 doesn't work, 1.9.0 works. So we're going to say 1.9.0 here, and we can also choose a window size by just saying window.size equals 640 times 700, for example. I'm not sure if this is going to work on Android, though. Maybe we're going to have to remove it. But that is actually the application. So I can say 12 times 9 equals 108. Then I can clear. I can say 8.9 plus 3 is going to be 11.9. Now I'm curious to see if 0.1 plus 0.2 will equal what I think it will equal. Yeah, there you go. We have a floating point error. We can, of course, take care of that if we want to. I have a video on that, why 0.1 plus 0.2 is not 0.3 in Python. So you can check that out if you want to. But you can see that it basically works. So if I have something like 8 plus 2 times 3, this will be 30. So you can see the calculator works. We now need to only compile it to Android. Now let's start with the compilation process. I'm first going to delete this because I don't think that it's going to be relevant to Android, to be honest. So that's the code that we're going to compile. And in order to do the compilation, you're going to need Linux. You're going to need either the Windows subsystem for Linux, you're going to need a virtual machine or an actual Linux system. You cannot do this on Windows only. I have explained this process in 2 videos already. So if you want to have a detailed talk about all of this, just watch my basic Android app development tutorial. All we need to do is we need to install Bulldozer, and we need to install it on Ubuntu using these commands. You can find them in the doc bulldozer.readthedocs.io. You just go to targeting Android. You execute all these sudo commands. If you're on Ubuntu and Arch, it's going to be different, of course. And once you have it installed, I have it on my Linux subsystem or on my Windows subsystem for Linux. We can use bulldozer init and bulldozer-v android debug in order to get what we're looking for. So what we need to do is we need to navigate to the directory where our application is. Also, I have a tutorial on this channel on how to set up the Windows subsystem for Linux properly. So everything you're asking right now, there is a video for it on the channel, the basic Android compilation process, and also the installing of Linux on Windows. Also, I have a virtual machine tutorial as well, so you will definitely find something. We're now going to navigate to the application. There you go. And in here, we're just going to call bulldozer. I already have it installed. Bulldozer init. This is going to create this bulldozer specification file, so I can say nv bulldozer.spec. This is basically NeoVim. You can use VI, you can use Nano, you can use Notepad if you want to. In here, you can set a bunch of different things. You can set, for example, the title of the application, neural calc, for example, calculator. Let's use a space in here. The package name is going to be neural calc, for example. The package domain is going to be org.neural, or let's call it com.neural, whatever. And you can choose the files that you want to include. You can choose a version, you can choose requirements, and you can also choose, let me just find where it is. You can also choose an icon. I don't know where it is. Icon. There you go. Icon.file name. You can uncomment that line. You can choose an icon for the app if you want one. You can use a pre-splash as well for the loading screen if you want to use it. All explained in the first Android tutorial. This is just some extra stuff. You can choose the orientation. You can set all sorts of things here, permissions if you need them. We're just going to go with that, what we have right now. So I'm going to write and quit. And I'm going to say bulldozer-v Android debug, like that. And this is going to start the building process. It's going to take quite some time. So I'm going to skip that part. Usually it takes 30 to 40 minutes on my computer. Maybe my computer is just not as good, so maybe it will be way faster for you, but it takes some time, and because of that, we're going to skip that part. All right, now once the process is finished, you should see that the build was successful. If that is the case, you should find a new directory called bin. Inside of that directory, you will find an APK file. This is the actual app. This is what you want to get onto your phone. You can use Drive, you can use Dropbox, you can use a USB cable, whatever. Get this APK file onto your phone, install it, open it, and then you should be able to see the app on the phone. However, on my phone, I saw that the layout doesn't look quite good. I think this is because of the static sizes in the Kivy file. Now, hopefully, I'm going to show you here what it looks like at the moment. I think just removing the height might actually fix that. I'm not sure about this, but we can try and see if that works. So we're going to delete height here. We're going to delete height here. And we're also going to delete it here and see if it works. Then probably it's not going to be that balanced. It's going to be quite stretched. And maybe we're going to have to fix that again. But once we have chosen that, we can also go ahead again and run this command again. This time it will take less time. And we're going to skip to the part where it's done. All right, so this ended up looking even worse. So we're going to now remove this size hint stuff here and hope this is going to fix that. If that is not possible, I'm going to look for a solution online. Let's try it. We're going to run this again and see what happens. All right, now this looks a little bit better, but it's still not good. So what we're going to do now is we're going to return to the size hints, but this time we're going to provide for the second parameter the ratio. So we're going to say this should be something like, what was it before actually? Was it 400 or something? Let's say 0.4 here, or actually 0.3 here, then go with 0.5 here, and then go with 0.2 down here, 0.2. There you go. We're not going to change the font size, of course. The buttons look kind of small, so you can increase the font size to like 30, 40, 50 or something. You can play around with that, but that's a minor thing. Let's run this again, and then we can see if it looks better now. All right, now this looks finally like something that is at least acceptable. Now, of course, the lower three buttons are a little bit too big, so maybe we should change the size hint to 0.1 or something. But in general, it looks kind of good, so kind of fine. So 86 minus 63 equals 23. There you go. Times 9 equals, then we can try again, 0.1 plus 0.2. There you go. And it equals 0.3000, whatever. So this is how the app looks now. I think I should be able to somehow put it into the video. Otherwise, you can see it here. Seems kind of fine from the layout. This is how you build a basic Android calculator app in Python using Kivy. So that's it for today's video. Hope you enjoyed and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you very much for watching. See you in the next video, and bye.